All right, so when we're talking about solving multiple variable linear systems, what that means is that you can have more than just an x and a y, okay? If we get more than x, y, z, then it's no longer a linear system. So it's just solving multivariable systems, all right? Now, the cool thing about, and this is just something to get you tempted to take trig and pre-calc. So this is a three-dimensional, oh, I need this one to be solid. We'll make this one solid too. So this is y, this is z, and this is x, okay? So this is a three-dimensional plane, not two-dimensional, but three-dimensional. How do I know it's three-dimensional? It's got three letters. All right, now the cool thing that you're gonna be working with in trig and pre-calc is you're gonna be learning how to do vectors and how strong they are and the direction and magnitude. If you think of Despicable Me 1, what's the villain's name? Vector. What does he say about him? I'm not going to tell you because that's going to be your bonus question for later on. Anyway, so what we happen to have is that we have an ordered pair. It's going to be x, not an ordered pair, an ordered triple. So it's going to be x, y, and z. All right. So if you can think about it, we'll say this is 1, and this is 1. So that means that this point right there is 1, 1, 1. Okay. And then you can start saying, well, 1, 1, 1 has a line going through it like that, and you get to start drawing it, and it really starts hurting your head. And then you get the TI-89, and it graphs it for you in three-dimensional shapes. It'll even graph your ellipticals, so elliptical spheres. So what we're going to be working with today is we are going to actually be using our own linear systems. So we're going to start with 2x plus 3y minus 4z is equal to 20. And then we're going to have 4x minus y plus 5z is equal to 13. And then we're going to have 3x plus 2y plus 4z is equal to 15. All right, so this is our first example. So what we're going to do is we're going to use a combination of two equations to eliminate one of the variables, okay? So what I mean by that is we could say, well, I'm going to use this one and this, the first and second one, and then I'm going to use, say, the second and third one, and then I'll use these two new equations to eliminate to one variable, okay? So let's just make it easy for ourselves. Do you want to get rid of the x, y, or z? We can get rid of the z, but it's going to be lots of math. Y, I would go with the y. Do you, and you want me to tell you why? Because there's one right here, right? And I can use that to get rid of it. Remember how we did that scalar multiplication to get rid of one of the variables? We're going to be doing the same thing with these two here, okay? All right, so this first one, I'm not going to change, okay? So I'm just going to write it down for you. I'm going to try and show you all the work that I can, okay? Now, I'm going to take this one, and I want to get rid of the y's. So I need to multiply. If that's a 1, I need to multiply it by, that's right, Shelly, 3. Good job. So I'm going to take 3 times 4, which is 12x, 3 times y, which is 3y, 3 times 5, which is 15, and 3 times 13, which is 39, okay? Now, the signs are opposite on the y's, correct? Correct. So if the signs are opposite, I am going to add those two equations together, okay? Why am I adding? So I can cancel out the y's And so since the signs are opposite, I just add them, they cancel out, okay? So 2x plus 12x is 14x, okay? 3y plus a negative 3y is 0, nothing. That's what we wanted. So negative 4z plus 15z is 11z. 20 plus 39 is 59. Okay, so that's my other new equation, okay? With me? Nothing really new yet, right? Okay, so the next one I'm going to do is I'm going to take this third equation and I'm not going to do anything to change it. Because I'm going to take it and this time instead of multiplying it by 3, I'm going to multiply it by 2. Why am I going to multiply it by 2? Okay, so I'm going to scribble that 3 out. I'm going to put a 2 in front of it. So 4 times 2 is 8x. 2 times negative y minus 2y. 2 times 5, 10z. 2 times 13 is 26, right? Good. Okay, good. All right, now signs are opposite, so should I add or subtract? Add. Nice. Okay, so 3x plus 8x, 11x, 2y plus negative 2y, 0. 4z plus 10z, I get 14z. 15 plus 26, 41. So far, so good? Sweet. Okay, now, here are, let's see here. How am I going to label this for you guys? So these are our two new equations, right? How did I get those two new equations? Using scalar multiplication and addition, we eliminated these two, got rid of the y, so we just have an x and a z. Same thing went with this one right here, okay? So now what we're going to do, and again, I'm going to give myself lots of room so you guys can see my work. So I'm going to go 11x plus 14z is equal to 41. That's my number 2. And then I have 14x plus 11z is equal to 59. That's my number 1. Now, could I have switched the stack of them in a different order? Yeah, definitely. Not, doesn't matter. Okay. Now, again, up to you guys. What variable do you want to get rid of? And this time the math is just going to be horrible. You want to get rid of the x or z? Yes, ma'am. Okay. So which one do you want to get rid of, the x or the y? Or the x or the z? I'm so used to x and y. X or z? X. Okay. So what do you think I need to multiply this guy by? 14. Because then I can just multiply this one by, we're going to multiply this one by 11. Okay. So 14 times 11, I get 154. And then 14 squared, or 14 times 14, is 196. 41 times 14 is 574. And then I need to do 11 times 14. Oh yeah, that's 154. And then 11 times 11 is 121. And then 11 times 59 is 649. Okay, now the signs are the same. So what should I need? What do I need to do? I need to subtract. Okay, so 154 minus 154 is 0. 196 minus 121. Excellent, beat me to it. And then 574 minus 649. Negative 75. What's my final step, guys? Divide by 75. And z is equal to -1. Now, we're going to take this z and we're going to put it either into that equation or that equation. Why would I want to do that? So I can find x. Does it really matter which one I'm going to use? No, because the math is horrible on all of them. Okay, so let's do this one. So I'm going to have 14x plus 11. What does z equal again? -1. What's 11 times -1? -11. So then what's my next step? I'm thinking I'm going to add it. 14x is equal to 70. And then 70 divided by 14. That's what I got. Okay, so now what's my last variable that I'm missing? Y. You have 3 equations to choose from. So let me show you what x was. X is 5. You have 3 equations to choose from. 1, 2, or 3. I'd do the middle one because y is 1. So let's go 4 times 5 minus y plus 5 times -1 is equal to 13. So 20 minus y minus 5 is equal to 13. So then I'm going to have -y plus 15 is equal to 13. And then I'm going to subtract 15. And I need to scoot this up. So I have -y is equal to -2. Right? And then y is equal to 2. Okay. Questions? Oh, answer. I got to write out my answer. So my answer is going to be 5, 2, -1. An ordered triple. So this is our second example. We were just talking as a class which variable to cancel out. So we're going to cancel out the x's because the x is 1 here, okay? So what I've done is I'm going to sit there and say I'm going to take care of this one and this one, so the first and third one, first and second one, and work at it so then I can get rid of the x's, then I can work on getting rid of the y's and the z's, okay? So we're going to work on that because I'm running short of time. Okay, so we have done the first, this one right here, so we multiplied that first equation by 3. We subtracted them because the signs were the same. So we got -3y minus 6z is equal to 7. And then we come down here, and then we got -3y minus 6z is equal to 7. Now we're going to take those two equations. We're going to see what happens. You already can see that that they're the same, correct? Okay, but we got to be careful with this. The signs are the same, so therefore I'm going to subtract, right? Okay, so we're going to subtract. -3y minus 3y, 0, right? -6z minus 6z, 0. 7 minus 7, 0. Okay, now, is this true? This is true. Okay, so if it's true, what's my answer? Infinite many solutions. All right, so this one was true. If we come up with a false statement, correct. So if I did something like 0 is equal to 14, right? This is false, and it would be no solutions. Okay? That's it. Okay?